Hi, I'm going to talk about feed-forward control. I'm Fernando Ortega Araujo, and let's do it. What is feed-forward control? Feed-forward control differs from the feed from feedback control in that the load or primary disturbance is measured and the manipulated variable is adjusted so that the deviations in the control variable from the set point are minimized. The controller can then reject disturbances before they affect the control variable. For accurate feed-forward control, steady state or dynamic analysis should be the basis for the models that relate the effect of the manipulated and disturbance variable of the control variable. Now, we have an example. I have an example. It's an animation feed-forward. We have the image. We have something new, and we have one question, three questions, sorry. Make a block diagram of the single loop composition control. Set the PID controller with three actions knowing that the transfer function linking the fuel flow with the output temperature is properly modeled as GPS delta Ts over delta FCS that is equal to 0.7 e to the minus 1.4 s over 8s plus 1 times ss plus 1, and develop a strategy of advanced control feed forward, considering explicitly the temperature at which the oven is fed. Evaluate the compensation needed, block diagrams and PI. The transfer function that relates the disturbance to the control variable can be assumed to be equal to GDS equal to delta TS over delta T0S that is equal to 0.8 times minus 1 to the minus 1.4s over 6s times 1 plus 1. Now, answer number is really easy. It's only do the block diagram. Now, um, uh, we we are going to go to the next question. Answer B. It's using a Sigler and Nichols methods in closed loop. GCS times GS it's equal to KC times 4.8 times 0.7 e to the minus 1.4s equal to 8s plus 1 times 6s times plus 1 times 0.5. These are values given by the problem. We have omega u equal to 0.448, tu is equal to 14, and kcu equal to 4.39. With the recommendations of Ziegler, at Nikon, it turns out that we get KC 0.26, TL7, and TD 3.5. Now, the last question that the last answer, that's the one that we, it's, how do I say, it's the important one. We now we see it seems that it's the same image as the first as the problem, but it's different. We now get a TY1 that connects to TY0 that connects to TT0, which it's connect to T0F. Now we have to make again the diagram, the block diagram, to know to know what are going to do, to know what are we gonna do to know the answer of this question. Now, the temper transmitter is similar to the feedback loop. G apostrophe TS is equal to GTS equal to 0.5. First, we must see how the forward motion corrections in a UCO relates to that of the feedback controller UC. To analyze if it is combined as sum or as a product, there are that relate the control variable to the two process input variables, manipulation and disturbance under steady state conditions. In this case, they are linked through the energy, like this equation FCHCN, and we get the equation of T. Now, since the control variable is a combination of the other two, it is established that the advance is linear and the signal must be related through of another, like like I shown right now, GCO, a summer with GC, and the new equation. Now, first, I'm not sorry. Uh, to synthesize the compensator, the input delta T0 must be related to the output delta Ts, like this. Now, for the effect of T0 changes on the control variable to be 0, the numerator must to be 0. GDS plus GTS, all of that's going to be 0. So we get GCOS, it's equal to GDS over G apostrophe TS times GCOS times GBS times GPS. So for this particular case, we got GCOS it's equal to minus 0.8 over 0.5 times 4.8 times 0.7 times 8s plus 1. As this is a non-causal element, a similar one must be used that achieves similar compensation. Since a lead lag is available, the compensation will grab the transfer function GCOS equal to 0.848 s plus 1. Well, this is the simplifications of number 4, and the equation we got is GCOS it's equal to 0.48 times 8s plus 1 over 0.8 s plus 1. A time constant as small as possible is placed in the denominator. It's usually 10 times less than that of the numerator. If the compensator is only a gain, in this case is 0.48, then the compensation is only static. And that's all. Thank you.